How does a water tower create water pressure? It might look like a giant tank on stilts, but a water tower is actually a simple engineering trick using gravity. When water is stored high above the ground, it has potential energy. That means it has stored energy because of its height. The higher the water is, the more pressure it can create at the bottom. That pressure is what helps push water through underground pipes and into homes, schools, businesses, sinks, showers, and fire hydrants. So the tower is not pushing water with a motor every time you turn on the faucet. Gravity is doing a lot of the work. Imagine holding a bottle of water above your head with a tube coming out of the bottom. The water wants to flow downward because gravity is pulling it. Now imagine raising that bottle higher. The water has more height above the outlet, so it pushes down with more pressure. A water tower works in a similar way, just on a much bigger scale. Inside the tower is a huge tank filled with water. That tank is connected to the town or city's water pipe system. As long as the water level in the tank is higher than the buildings and pipes it serves, gravity can help push water through the system. That is why water towers are tall. The height matters. Engineers use the height of the water to create pressure. A common rule is that every 2.31 feet of water height creates about 1 pound per square inch of pressure. That means if the water level is around 100 feet above the pipes, it can create about 43 psi of pressure. That is enough to help water flow through faucets, toilets, washing machines, and other systems. But the water does not just magically appear in the tower. Pumps are still used. The pumps move water from the water treatment system or underground supply up into the tower. But here is the smart part. The pumps do not need to run every single time someone uses water. Instead, they can fill the tower when demand is lower, like overnight. Then, during the day, when lots of people are showering, washing dishes, watering lawns, or using water at school and work, the tower helps supply pressure. The tower acts like a giant water battery. It stores water and pressure for later. This also helps during power outages. If the power goes out and the pumps stop working, the water tower can still provide water pressure for a while because the water is already stored up high. That can be really important for drinking water, basic use, and fire hydrants. Water towers also help keep pressure more steady. Without a tower, pumps would have to constantly speed up and slow down as people use different amounts of water. That would be harder on the equipment and could make the water pressure less reliable. The tower smooths things out. When demand is high, water flows out of the tower. When demand is low, pumps fill it back up. It is a balance between storage, height, pressure, and gravity. The shape of the tower matters too. The tank needs to hold a huge amount of water safely. The legs or support structure need to carry the weight of the water, which is extremely heavy. 1 gallon of water weighs about 8.34 pounds. So a tower holding hundreds of thousands of gallons is supporting millions of pounds of weight. That is why water towers are not just tanks. They are engineered structures. They have to handle water weight, wind, weather, corrosion, freezing temperatures, and pressure changes over time. So when you see a water tower, it is not just there as a backup tank. It is part of the pressure system. It stores water high in the air so gravity can help move it through the pipes below. The pumps lift the water up. The tower stores it. Gravity pushes it back down. And that pressure is what lets water come out when you turn on the faucet. That is how a water tower holds up the pressure.